Now we're going to evaluate an expression. So what they're going to do is they're going to give us an expression with variables, and then they're going to give us values for the variables. Generally, that's how they approach these types of problems. So we should get a numeric answer here. So I can't spell an answer. So it doesn't always work that way. You can evaluate an expression with another expression, but for our purposes, they're going to give us values for the variables. So we'll look at example 7. We have an expression right here, 8x minus 3, but then they tell us in part A, x equals 2. So we're going to take out the x and we're going to replace it with 2. Now notice that I put in parentheses around the 2. I need that to indicate that it is multiplication, or I could have used the dot for multiplication. I don't want it to look like 82. Now, once I have all the variables have a value, they've been replaced with a number. Now it's a numeric expression. We can use the order of operations. We're going to multiply first, so 16 minus 3, and then our answer is going to be 13 here. All right, now they want us to evaluate the expression. So 8x minus 3 still, same expression, but now x equals 1. This is part B. So 8 times 1 minus 3. You're replacing x with a different value this time, but you do what you're told, and in part B they tell us x equals 1. So we have 8 minus 3, which is 5. All right. Now, example 8, I didn't want to do this one, but I'm going to because it's in the book and you might see it and you might think, wow, I'm really confused. This is an odd way that the book had of writing this. It says evaluate x equals 3 when a equals x squared. It's really, they want you to take the x squared and they want you to put in x. Okay, so I wrote that wrong. Take the x squared and put in the 3. I did it again. X squared and put in the 3 for x. So we know x is 3 because they tell us that at the beginning. I really think the question's kind of misworded, but 3 squared means 3 times 3, which is 9. So that's the value you would get. Now look at the other problem. You have 4, a base of 4, to the exponent is x. And so the variable is in the exponent. So we want to evaluate and make it 4 cubed because x equals 3. So that means 4 times 4 times 4, which is 64. So, and again, you work that out on paper or somehow. Okay, example 9. The expression's a little bit bigger here. You've got 3x squared plus 4x plus 1, and now we're going to let x equal 3. Notice that x appears twice in the expression. X is going to be 3 in both parts. So it's going to be 3 times 3 squared. Notice I used parentheses because I want to make sure I do the exponent part first and then the multiplying. Okay? So it's really important that you put the parentheses in right. Plus 4 times 3 plus 1. And so the 3 there, or the x there became a 3, and the x there became a 3. But that notation is important. You don't want it to look like 33 squared, and you don't want it to look like 3 times 3 and then squaring that. So you have to follow the order of operations, and sometimes it's easy to get confused. All right, so we're going to do the exponent first. In fact, I'm going to put a little box around it. The exponent part is that. The multiplication part is then going to be times 3, but so we want to do 3 times, 3 squared is 9. 3 times 3 is 9. And then plus 4 times 3 plus 1. So now we're going to do the multiplication. 27 plus 12 plus 1. And then we have to add those up. So what do we get? 39 plus 1, or 40. So notice that you're going in steps, down and just doing one step, or, I did the multiplication for those two parts because they were separate, but, one part at a time. If you keep it neat and orderly and Hopefully it'll all work out for you. I like these problems. These are a lot of fun. Okay. See if I have anything else. Nope.